Good morning. We're here to talk about the decarbonisation of heat. Heat is a huge contributor to our carbon footprints, but the solutions to it are pretty complex and fairly varied. We see regional variations between different countries. We see variations between the kind of solutions that are required to decarbonise domestic heat versus industrial heat. To talk about this, I'm here joined by Matt Moran, David Sanders and Andrew Burrows. Welcome, everybody. Great to see you. Matt, perhaps we could start with you. Would you like to just talk a little about where heat sits in the priority stack of our decarbonisation journey?
Sure. In the U.S., what we've learned is that, states have their own policy. And in looking at areas like Washington State, New York State, Massachusetts, California, and so on, the basic playbook is aspiring to achieve a clean energy economy. And typically that's in the 2040, 2050, 2060 timeframe. And the standard playbook for that would be clean the power supply, decarbonize the transportation sector, and then decarbonize the heating of homes and businesses. And what you're left with generally is 70 to 90% of a clean energy economy overall. And then you still have industrial, agricultural left to tackle depending on region.
So in that context, is there a single technology choice that will help us get there faster? Is it clear yet what our decarbonisation of heat pathways are, Andrew?
So it's not straightforward. There are really two technology options in play now. One is hydrogen, and that's the ability to use the existing boilers or upgraded boilers using the distribution network, the natural gas distribution network, converting it progressively to hydrogen, and then having boilers in domestic properties and commercial properties that use the hydrogen and burn it. So that's one pathway. And the other is electrification. And this is the use of heat pumps. Heat pumps effectively amplify the thermal energy in the atmosphere. They're very efficient. They connect to the electricity grid, and they generate heat by transferring heat energy from the atmosphere.
Fantastic. And that's a very interesting point about efficiency. Does that also correlate with a more carbon efficient choice between the hydrogen versus electrification debates?
There's the challenge in terms of availability of those green electrons that are going into the value chain at the beginning. There's a competition, really. Where are those green electrons best utilised? They're both equally carbon efficient once the natural gas network has been converted to hydrogen. So once that is the case, they are both similar, they are both the same from a carbon perspective. But the efficiency has a big impact on how quickly this can be scaled, because it requires the building out of photovoltaics and wind farms to generate those electrons.
So, David, in thinking about decarbonising the commercial and residential sector, any particular nuances or trade-offs that you'd like to comment on?
I think so. Thanks, Amy. The economics of the trade-off between heat pumps and hydrogen really varies by region. In the Nordics, the energy efficiency of buildings is incredibly efficient already, and they've got district heating networks that work really well. At the other extreme, you have countries like the UK where the housing stock is highly inefficient, so you have to look at the economics in a very different way. You also have to think about, when you're considering hydrogen, what is the optimal use for that green or renewable hydrogen? If you've got a target for a country of 10 gigawatts of hydrogen production, which some countries have by 2030, that's maybe enough to power 3 million homes to provide their heat, which isn't much. And that hydrogen is required by all sorts of other industrial demands. The ammonia plants want it, the refineries want it, some of the power generators want it, some of the truck manufacturers want it. Is the best use for use that hydrogen in heating buildings? Certainly the companies that own gas networks don't want any stranded assets, and they'd like to reuse their gas networks for hydrogen. But what's the best from a system perspective? And we have to ask ourselves that question.
Fantastic. That's absolutely fascinating. And I think we come time and time again to this theme of needing to take a full system view as we walk through the transition together.
There are opportunity costs all over the board, that's for sure.
And how does that the experience that David just described compare to your experience in the US, Matt?
Well, what David just described is very consistent, and obviously there's a great variation in terms of climate differences. So, as Andrew could explain, you get a lot less utility the colder the weather is, and so ultimately when you're talking about just residential heating, the more sort of northern the climate is, the more difficult the economics become, and that's where the need for government subsidies or incentives comes into play in order to sort of accelerate the adoption rates as it relates to at least heat pumps per se, and definitely agree with the opportunity cost in terms of using hydrogen, for example, in industrial processes relative to long-haul trucking. That's a significant question as hydrogen hubs begin to sort of really take hold.
So at the moment, there's quite a lot of good targets for decarbonising buildings, long-term targets, but there isn't much sort of almost rational debate on what the economics are of heat pumps versus hydrogen. What are the installation costs, which vary, as Andrew was saying. If it's a new building, it's totally different to an existing building. Some buildings are off-grid. In the UK, over, I don't know what, 4 million homes are off-grid, so they have to be heat pumps. Yep, they're not going to be connected to the gas grid. But working through those economics, what is the best choice in different countries, which is going to vary, and for different types of buildings in different areas.
And the other thing we were talking about the other day was the impact public sentiment has on public policy overall. And so when you think about the spectrum of adoption rates, whether it be rooftop solar or electric vehicles or heat pumps, for example, from a residential point of view, ultimately the sort of consumer perspective is a bit more flashy or perhaps more branded on an individual basis with electric vehicles, with rooftop solar, but it's kind of difficult to brag about the heat pump application, buried in your basement in the case of the U.S.
And you've got the tenant landlord challenge. Yep. You might live in a house that's owned by someone else who's operating on low margins and they're not incentivized to invest in either hydrogen or a heat pump solution.
I think the consumer angle is a particularly interesting one for all of those reasons. So I'm thinking about the kind of global experience of rolling out smart meters and some of the barriers that we're seeing in lots of places where simply about getting through a door and getting something which isn't very flashy or very sexy kind of changed out with a resident. So I think there's also a debate to be had around how you engage people in a way which is perhaps going to be disruptive to their day-to-day life as well.
It's also worth noting that the heat pump technologies are evolving rapidly. The hydrogen boiler applications are pretty much an established technology. And there's not a great deal of change going to happen in those technologies, but the heat pump application is new, particularly when it comes to the technology for retrofitting to existing properties. So we are seeing a great deal of change happening in that space. Organizations are investing a lot of money to make them cheaper, to make them easier to install, to improve the efficiency, to reduce the cost. So I think that's going to have a big impact, and it's going to make it more easy for people to adopt them because they'll be smaller and they'll be more cost effective.
And does that come, in your view, with a potential stranded asset risk in the shorter term if the technology continues to evolve so rapidly?
From the perspective of networks, I think it's unlikely that the networks will become stranded because there are so many demands for intense heat from an industrial perspective and so many buildings and properties that will struggle to adopt heat pumps. So I think it's unlikely that there will be stranded assets. My view is that there will be a blend of the heat pump and the hydrogen technologies going forward.
The stranded asset risk really comes from the gas network companies that would prefer to use a hydrogen solution. That's where the stranded asset risk is, not so much in new heat pumps coming along.
Fantastic. That's good to hear. Thank you all for your time. Again, another fascinating and highly complex debate. I think we see this time and time and again as we talk about various themes around the energy transition, the interplay between policy, incentives, technological advancements, and consumer continues to be a fascinating one. So thank you again for your time.
Thank you, Amy.
Thank you.